Well, hello and welcome to this exercise in which we try to solve trig equations from past exam papers. And for this exercise, you're not allowed to use calculators, so you should not use any calculators in this exercise. There are three of them. So we have the first one says sine 2x is equal to minus 1, and then tan 2x is equal to 1 for values of x between 90 and 270 degrees. And also for the third one, it says sine squared x plus pi over 6 is equal to half for values of x greater than minus pi and less than pi. So we expect the answer to be in radians. Okay. Now, if I then say let a be 2x, you don't have to do that. So we're looking for sine a is equal to minus 1, looking for the sine of an angle with value of minus 1. Now, you will expect, because it's minus 1, you will expect values in the third and the fourth quadrants. But as you know that for sine 90, and sine 90 is between the first and second quadrants, and that gives you a value of 1. You will expect, therefore, that the sine with a value of minus 1 will be between the third and the fourth quadrants. So the answer we have is 270 degrees. And because the sine circle repeats itself every 360 degrees, so we'll expect the next value will be 360 plus 270, and that gives us a value of 630 degrees. So sine 630 degrees is minus 1. Now you can check it out yourself. So we now have that 2x has got values of 270 and 630 degrees. If we then half both sides or divide both sides by 2, we end up with x has got values of 135 and 315 degrees. And those should be your answer for the first one. Again, no calculators. Right, for the second one, it says solve tan 2x equal to 1. If I say to get 2x is equal to, if I say let 2x equal to a, we then have that sine a is, or a has got values of 145, because don't forget you're not allowed to use calculators, but you're supposed to know that if you drew an isosceles triangle, an isosceles right angle triangle, as you have in this case here, so that's 45 degrees, that is also 45 degrees there. Now if you divide that side by that side, divide the values, that is, you get a ratio of 1. So the tan of 45 would be 1. And because the tan cycle repeats itself after 180 degrees, you have 180 plus 45, and the next one will be 180 plus 180 plus 45, and the next one will be 180 plus 360 plus 45, and so on. So that will be your term values now. So you then end up with 2x equal to 45, 225, 405, 585, 365. Now we're looking for values of x between 90 and 270 degrees. Now clearly that would be too small, okay, and that's probably too big there. So if you then divide by 2, the values we require for 2x will be these two and that one there. So if you divide those by 2, you end up with x being 112.5 and 202.5 degrees. Now for part C, and now we are told that sine squared x plus pi over 6 is equal to half. Now for this exercise, I'm going to work in degrees and then change to radians. So if I say that x plus pi over 6 is same as h, so sine h will give me a value of half. If I then take the square roots of both sides, I end up with the sine of h being plus or minus 1 over root 2. Now, again, because this is a non-calculated paper, you should know that if you have, again, a right angle isosceles triangle, and that's one there, so that's 90 degrees, and that's 90 degrees there. Now, if you assume that the value of each of these sides is 1, so that's going to be the square root of 2 there from Pythagoras. Oops, sorry. Anyway, that should be 2 there from Pythagoras. So the sine of this angle of each of these angles will be 1 over root 2, and that's 45 degrees. Okay, so now we then have that y is 45 degrees, 135 to 25315. Now, what I've done here, because the sine cycle repeats itself after 360, I then add 360 to 45, and I get that one. At 360 to 135, I get that one. I get 360 to 225, and I get that one, and so on. So you don't have to do this, just as an exercise anyway. So that's what we got there. So we now have that that y is equal to x plus 30, because I'm going to change pi over 6 to degrees, which is 30 degrees. So which then means that your x value is 45 minus 30, and that's 15 degrees. Now 15 degrees is pi over 12. Now don't use calculators. You should know that you should know how to calculate, how to change degrees to radians. So if I do 15 there, divided by 180, okay, because 180 degrees is pi radians, and then multiply by pi. Now, if I divide 15 by itself, I get 1. If I divide 180 by 15, I get 12. So, in effect, 15 degrees is equivalent to pi over 12 radians. Similarly, for 135, if I subtract 30 from 135, I get 105. And because there are 7 15s in 105, 105 degrees will be 7 pi over 12 there. So that's the next answer. Now, what about the values of x lower than 0 or negative values? So what I do in that instance, don't forget you've not got time to do this in an exam. So what I tend to do, you haven't got time to explain using a sine curve. So what I tend to do is this one here. Minus 45 is equal to x plus 30, or x plus 30 is equal to 45 degrees. If I then decrease each of these by 30 degrees, I end up with minus 75 degrees and 15 degrees there. And because there are 5 15s in 75, so minus 75 degrees will be the same as 5 minus 5 pi over 12. And we know already that 15 degrees is pi over 12 there. Okay. Now, what about 225? Sorry, what about 135? Sorry. And what we then do, similar thing again. You then do minus 135 is equal to x plus 30, or x plus 30 is equal to 135. If we then decrease both sides by 30 degrees, we end up with minus 165 and 105 here. And because there are 11 15s in 165, so minus 165 will be 11 pi over 12 radians, and 105 will be 7 pi over 12 radians. So the answers required would then be minus 11 pi over 12 and 7 pi over 12, and also minus 5 pi over 12 and pi over 12, and those are your answers. Now, I hope all those made some sense, and please subscribe. Thank you for watching, and bye-bye now. Bye-bye.